So here's a short video explaining two questions that I missed on the practice final numbers 10 and 17. Let's jump to number 10. We have well, I'm already showing you the answer. That's horrible. Pretend you did not see that, okay? We have an equation that has variables in the exponents, okay? So if we want to solve for x, first of all, you don't want x to be the exponent. You don't want it to be a power of base 9. Okay, so what we know is that if we do have the same base, like if you have 3 to the x equals 3 to the second, if you have the same base, then you're able to just eliminate those bases and the x will come down, the 2 will come down, and the equal sign will come down, and there's your answer, x equals 2. So we would love for both of these bases to be the same. Actually, we need to change both of these bases to be the same. How are we going to do that? By rewriting 9 as exponent. Rewriting 27 as an exponent with that same base. So 9, we're going to rewrite that. We're going to rewrite the 9 as 3 squared. Okay, so instead of 9, we're writing it as 3 squared. And we still have the power 2x plus 7. And of course, we have the equal sign. And over here, instead of 27, we want to rewrite that in terms of 3 to a certain power. And we should recognize that that's 3 to the third power. And it still has the same power, negative x minus 7. Negative x minus 7. So now that we have the same base, 3 and 3, we'll be able to eliminate them and the powers will come down. But before we do the elimination of the bases of 3, we do have a power to a power. And right here we have the number 2 and the binomial 2x plus 7. So we know when we have a power to a power, we have to multiply. Power to a power, you multiply. That's a rule of exponents. So we're going to distribute 2 times 2x, that'll be 4x, and keep in mind that it's still as a power of base 3. So 2 times 2x is 4x, and then 2 times 7 is 14. And then over here we also have the equal sign, we also have the base 3, and again we're going to distribute, because we have a power to a power, 3 times negative x, that's negative 3x, 3 times negative 7, that's negative 21. So here's our new equation that has the same base, 3, which we can eliminate, giving us a new, simpler equation with variables on both sides. We have the 4x plus 14 equals negative 3x minus 21. Let me actually write that down over here on the side. 4x plus 14 equals negative 3x minus 21. So let's get the x's to one side. I'm going to add 3x. Add 3x. I will have 7x plus 14 equals negative 21. And last but not least, I'm going to subtract 14, giving us 7x, that canceled out, equals negative 35. Final step will be to get rid of this multiplication of 7 by dividing by 7, x equals negative 5. That is your answer. And if we look at our answers over here, we already showed you at the beginning that negative 5 is the correct answer. Let's go to the next question. Right here, they're giving us this equation, f of x, and we should recognize that, we could actually type it into Desmos if we'd like. We'd see that it gets reflected over the x-axis, that it gets vertically stretched by a factor of 5. It gets shifted 2 to the left and 5 up. But that's actually a waste of time if you think about it, because we know that an xy plane is right here. And we know that the asymptotes will be x equals h and y equals k. Okay, the asymptotes will be x equals h and y equals k. Now, again, what do these types of functions look like? They look like this. Y equals, you could have the a value over x minus h plus k. So you could recognize that the h value is -2. So the asymptote will be at x equals -2. That's one asymptote. The other asymptote will be at y equals a horizontal line, y equals 5, the k value, y equals 5. So it asks you to identify the asymptotes. That's the very first thing they ask. We know that it's x equals -2 and y equals 5. So there's your answer, x equals -2, y equals 5. And that would pretty much eliminate the rest of these because none of the other ones have a -2 or a 5. But let's say on the actual test, other ones did have that. Then you could move on to the domain and range. Before we actually talk about domain and range, let me actually sketch this, all right? We already know that our asymptotes are at x equals -2. So here's your vertical asymptote. That's x equals -2. And your horizontal asymptote, y equals 5. 1, 2, 3, 4, 5. This is your horizontal line, y equals 5. Now we know that if your a value is positive, it's on the lower left and upper right. But because this one's negative, it got reflected. And anyways, this is just a sketch. It's going to look something like that, going that way, and something like this. And of course, you could use Desmos to verify this. But it's easier to just think about it the way I just did on paper by sketching it. So what about the domain? The domain of this sketch, or you could look at it on Desmos, does it go to the left forever? Yes, it does. Does it go to the right forever? Yes, it does. So the domain is all real numbers, D, all real numbers, but x cannot be the -2 value. So x cannot be -2. So I hope that makes sense to you, that x cannot be -2. Maybe I shouldn't have written it. It's getting ugly. Sorry. And the range is the same thing. Everything up, everything down, but it can't be the y value, the asymptote y value of 5. Okay, so the domain, all real numbers, but it cannot be -2 because that's the asymptote. And the range, the y values could be all real numbers, but y cannot be the asymptote 5. So that's the explanation. I hope this helps.